So we're going to be continuing our lesson that we started yesterday about like sensation and perception. But here's the thing. I know I told you that we were going to use the very beginning of class to find our blind spot where our optic nerve is. And we will. I just forgot that we were testing today. So we will be doing that tomorrow on Thursday. So we're going to continue talking about sensation and perception. You can on your little packet that has like the eye and the ear on it that you got yesterday, you can take notes in the packet, or you can take notes where you normally do. But let's continue our talk. So um, there was these two psychologists, Hubble and Weissel. They did studies with the brain to figure out, like, are there different parts of the brain that recognize different shapes? And spoiler alert, yes, there are. And they're called feature detectors. So they're nerve cells in the brain that respond to specific stimuli. And I believe, if I remember correctly, they had patients and participants in this study look at like different times on a clock, and like the different angles of like the hour hand and the minute hand made different parts of the brain like light up. And so certain parts of the brain are responsible for like looking and recognizing particular shapes. And so with brain scans, we can tell if a person is looking at a show, a chair, or a face based on different parts of the brain that light up. And they also use the Necker cube, which you probably have doodled before. It's at one point in your life. And whether you see the square is like, do you see that this is the front, or do you believe that this square right here is the front? And going back and forth, different parts of the brain will light up. So I guess one part of the brain is supposed to see an angle, downwards angle, if you believe that this is the front, versus an upwards angle, and then this square right here is the front. Okay, speaking of color vision, hopefully everyone can see the number that is in this little patch of circles. This is a colorblind test. You should probably see the number like 71 or 74, but people that are colorblind do not see any, they do not see the green circles that are in this little test. My husband, he's colorblind. He does not see. They all look like different shades of like brown. He cannot tell. So I don't know why that all popped up at once, but we talked about yesterday, like, is the stapler red? And we said no, it's everything but red. And that's kind of the riddle of the tomato. Is like, what color is a tomato? Because of light, a tomato is everything but red. It absorbs all the colors of the rainbow, and then the red light wave like bounces back to your eyes, and you see red. So there are two theories of why we see color, and each of them have their supports, and each of them have of like they lack the whole story. So that's why there's still theories. Okay, so one theory is the Young-Helmholtz trichromatic theory. And this theory explains why people are colorblind, because it explains that we have like three different cones in our eyes. We have red, green, and blue. And those three colors help us see all colors. They're not even the primary colors, because it's the primary colors red, yellow, and blue. But so it's not that. It's red, green, and blue that the three colors are. And so this explains that people that are colorblind and can't see this number in the circles, they're missing one of their cones, which is why there's different types of being colorblind, because it's depending on the cone that they're missing. And so if they're not color blind, they can still see color. They're just deficient in the amount of cones that they have. And this, I'm not going to click this because I might be breaking copyright laws because it goes to a YouTube video, but you can go to the slides that are on Schoology and see this. This is people trying on those like Enchroma glasses for the very first time that allow colorblind people to see color. It's a great video. It's an emotional video because color is a personal experience, and it is an emotional experience to see color. And that we, people that do see all color and they're not color deficient, they take for granted the fact that they can experience color. Another theory of why we see color is the opponent process theory. And this doesn't explain why people are colorblind, but it does explain after image effects. And so this talks about how each color has an opposite. And these two opposites work in harmony in our retina to help us see color. So the opposite of black is and white, the opposite of green is red, the opposite of blue is yellow, and those opposites will help us see together because they work together. So for example, here's an after image effect for you. Oh, I did not do that. No, I don't want to break copyright laws. Okay, there we go. So, if you stare at this image, just keep on staring. You can pause and stare. You see right now that there is a flag that is yellow and black and green. And the opposite of yellow is blue. The opposite of black is white. The opposite of green is red. So right now, the receptors in your eye that see yellow, black, and green, keep staring, are getting tired. There, you can probably feel the strain in your eyes of just like your eye is tiring after staring at this image. But if I go back to if I go to a blank page, you might have seen for a split second an American flag like after image effect. Well, this gives evidence that the opponent process theory works, that they do work in harmony. You are exhausting your receptors for black and green and yellow here, and so you're tiring up like that muscle. It's not really a muscle, but you're tiring out that receptor. And so when you stare at like a white image, you actually see the opposites because they work together in harmony. You tire out one, the opposite will come true. Same thing here. Here's another picture that you're going to have an after image effect with. So if you stare at these four little dots here in the center and stare, just like before, you can even pause it. You might have for a split second see like a picture of Jesus. And so that is an example of an after image effect. Okay, let's talk about more optical illusions. There is no movement on the screen. Your brain sees movement. So this illusion is not happening in your eyes, it's happening in your brain. Same thing here. This is the Hermann Grid. This is you actually see little gray spots in the intersections because your brain is in nature. We're not used to seeing such like stark differences between black and white, and so your brain actually fills in some gray because that's more realistic to what you would see in real life. You would not see images like this, so your brain tries to fill it in and tries to blend it out. Another different types of optical illusions. Oh, just kidding. Like this is like the face. Do you see two faces, or do you see the face? And you're using like this image to like is it the background that's the image, or is it these dark figures that are the image? This is a very common, popular optical illusion. Several of you might see an old lady. Several of you might see a young woman. So you might see, if you see the old woman, you might see this as her chin. This is her mouth. Her nose is like this, and this is her eyeball. That's the old woman. She's kind of like this whole thing is her face, and she's kind of like looking down into her fur coat. Or you might see a young woman. The young woman, this whole area is her neck. This is a necklace. And she's actually facing away from like the camera. This is her chin, and she's looking away because that's her nose, and this is her ear, and she's like looking past her shoulder. And so that could be the young woman or the old lady, depending on what you see. All right, let's continue our talk about this time perception. So, unfortunately, I cannot show you this clip because if I'm recording this, I'm going to be breaking copyright laws. And so, selective attention is like when you focus your attention on something in particular, it's very possible that you become blind to everything that happens around you. So, like maybe you're it's called the cocktail party effect because they always say, like, maybe you're at a cocktail party and you're having this really intriguing conversation with someone. And then the next day they're like, oh my gosh, did you see what so and so was wearing? Or did you see what they did? And it's like, no, I didn't. It's like, are you kidding? It happened right next to you. They were right next to you. But you were so engrossed that because you were selecting your attention on this conversation, you totally missed things around you. If you go to the slides in Schoology, you can actually take a little test of selective attention, and see how many times people pass like a basketball back and forth to each other, and see if you see anything else that pops up. Unfortunately, I cannot show you this video right now, but if you go there, it's like a maybe a 2-minute video, but I'm sure several of you have seen it before. But that's an example of selective attention. And I also have another example of this one is they do it in Brain Games. I don't know if they still have Brain Games as a show anymore. But it's like two people are having a conversation and someone walks past them or like through that conversation. And in that process, person A is switched out. And like another person takes their place, and does person B that's also in that conversation, like, did they notice that the person they talked to has changed? Like they just walked away and someone else was replacing them in the middle of the conversation. Did they even notice? And a lot of people don't. They just go into the conversation without realizing that they're talking to a completely different person. Okay. Concepts that are always tested on the AP exam is bottom up processing versus top down processing. So bottom up processing, you always draw this like upside down triangle. So think of this as like it's really wide, big concepts versus really small, tiny points and very specific details. And so bottom up is like you start with these details and then you make a bigger, wider, like perception over the whole thing. So you start with your sensory receptors. You try to bring in, like, you look at the details of this picture. And you're like, what am I looking at? You're trying to focus on the details and then try to perceive what you're looking at by focusing on the details first versus like big picture. So this would be someone that if they're going to read a textbook and for their class, they're going to be looking at like they're going to be like reading the whole textbook, and then they're going to be like, okay, let me look at the titles now. Let me look at the bolded words. But they're going to focus on the small details first and then try to work their way out. While top down processing is people that they're going to look at the titles first and then read. They're going to look at the big bolded words first and then read. They're going to look at the big picture stuff and then focus on the small details. So they're guided by higher level mental processes. And then they try to draw on their previous experiences of like what they think that's going to be about. They kind of look at the big picture first before they focus on the details. And so this person might be like, okay, so big picture, what have I seen that's black and white? What have I seen that's like spotted? And that might help them see that this is a picture of a Dalmatian. This is a Dalmatian walking away from the camera. There's a tree here. This is the shadow of the tree, and the dog is right here. Their nose is to the ground, and they're in the middle of a stride. Here's another example. This example is like, okay, so you can use top-down processing and focus on the details. Sorry, bottom up processing and focus on the details first and be like, okay, what's over here? What's this thing over here? What's going on over here? Or top down would focus on like big picture of like, okay, try to take a step back and like try to take it all in before focusing on the details. And maybe you've seen this picture or not. This is a more likely you're going to get this question right in a place like Tomball of like what this picture is versus like in a big city, because you are looking at a cow. This is a cow. This is the head of the cow. We got the ears of the cow here, and it's looking directly in the camera. Here's the back of the cow. Okay, let's talk about some more illusions. So this is actually do a brief, probably sketch in your notes. You can draw it like this with like the curved ends, or you can draw it like this with the like arrow looking ends. This is the Mueller-Lyer illusion. Lines A and B are the same length. You can get out a ruler and measure it yourself, but people perceive B as longer because of the ends. It kind of lengthens the line. And even though we could measure it and we know that A and B are the same, because vision is our dominant sense, we are more likely to have like visual illusions rather than any other type of other sense illusions, because we still are going to perceive, even though we know we get in a ruler, we know that A and B are the same. We will still perceive B as longer, even though we know the correct answer and that they're both the same length. But visual captures our tendency for our vision to dominate other senses, like touch, and I can feel that they're the same length, or I can measure it and I can see, but we're still going to perceive B as longer even with that knowledge. Um, you might have, so there it is. Uh, in Unit 1, I believe this is mentioned in one of our beginning homeworks, the idea of Gestalt. Gestalt is not a person. This is not a name. This is it's German, they say, for the word whole or the word form. And so this is how we also, another example of how we perceive. And so, like, these are different Gestalt principles: proximity, similarity, continuity, closure, and connectedness. And so, like, we perceive based on proximity. We are more likely, instead of perceiving this as six individual lines, as three groups of two. Just because these two lines are closer together, we perceive them as being together. Same thing here. We see this more as columns as opposed to rows, because these are similar. So these triangles must go together, these circles must go together, and these triangles must go together. So we perceive these typically as like columns instead of rows. Continuity. Most of us perceive this as one long, continuous, like curvy line rather than semicircles. The semicircles is hard to perceive that as like this, they're disjointed, because it's easier to see them as connected. Same thing with closure. And I've got examples of closure right over here. We see this as like a triangle, um, or we see this as like a worm wrapped around like a cylinder of some kind, or here's a sphere like that has points to it. Because we like closed objects, we like to see things that are neat and closed. So if there's like a half circle that's missing a portion, we're going to view that still as like a circle, even though it's not a continuous closed circle. And when things are connected, we're more likely to perceive them as together. Like, we perceive this as little, like three little dumbbells versus circle line, circle space, circle line, circle space. Like, that's hard to perceive it that way. And another illusion, the moon illusion. The moon seems to be smaller when in the sky, but because of the horizon, we see horizontal lines as wide, which is why people, if they're trying to look like they're thinner than they actually are, should not wear horizontal stripes. That's just going to make them perceive longer. And so when the moon is close to the horizon and the horizon looks so wide, the moon seems to be bigger when it's up in the sky. Here's another illusion called the Ponzo illusion. It's very similar to that Mueller-Lyer illusion of like lines that are the same length, but they're not. So that we see this line up here longer than this line down here. We perceive it as longer and bigger. And we also perceive like these horizontal lines to be like thicker than these like diagonal lines, when they're not. They're the same length. These two are the same length. And then these all four of them are the same width. You can, here's Philip Zimbardo uh, in a Ames room. It is a optical illusion room. You can watch that video. I think it's only like 2 minutes long, about different perceptions and how we perceive distance. Okay, another one I can't show you, but you are more than welcome to open up on things on Schoology. You probably have seen this. Uh, it is a 3D painting that our brain actually inverts, and you probably have seen similar things here. If you've seen this T-Rex, it's a cardboard T-Rex, but it looks like it's coming at us when really it's concave as opposed to convex. Same thing with the Charlie Chaplin mask. It looks like it's coming out at you when really it's inverted and it's concave. Okay, we're almost done. Let's see how far I wanted to go. That's it. Okay, and last thing today. When we are parallel processing, When parallel processing are like depth, movement, shape, um, and color, or processing all those things. One of them we process form, which is shape, and we use the foreground, the background, to help recognize like the shapes against it. So, FedEx uses the idea of figure ground to show speed, I guess, because FedEx, between the E and the X, there's this white arrow that is made from the background. The white background makes this arrow um, between the E, the capital E, and the lowercase x to represent like fast going, or, going forward. Same thing with Amazon. Amazon is just using the figure though; they're not using the background of like it. They have everything from A to Z. Also, the Z is a little curved right here to represent like a smile. So this looks not only like an arrow, but it's a smile as well. So not only do they have everything A to Z, but it's trying to invoke the idea of like happiness and joy. So a figure is just the shape, and the background is just anything behind it. And so like the FedEx words are the shape, and then the white is the background. Same thing here was the that face and the vase, um, optical illusion, I guess. It's like, do you see the two faces that the background is making, or do you see this figure of the vase? That what do you perceive first? Do you perceive the background, or do you perceive the form? Okay, that's where we're going to stop today. Um, you don't have homework tonight, but you will have homework tomorrow night. And then we're going to be finishing up our perception, sensation and perception. I've got some optical illusions to show you in class tomorrow, and we are going to find our optic nerve. But remember, this Friday is Unit 2 and Unit 3 vocabulary quiz. So if you haven't, go look at those Quizlets on Schoology. There's one for Unit 2, which is like brain and neurons, biological basis of behavior. And then there's Unit 3, which is sensation and perception. But those are closed note quizzes on Friday. So let's make sure that we're prepared for those. Remember, they're longer than a normal quiz because there's more vocabulary words, and it's closed note. So let's end Unit 3 on a good note. All right, guys, have a good day.